In this question, it is given that the number of functions f takes the set containing elements 1, 2, 3, 4 to this set, satisfying the condition that fn plus 1 by n fn plus 1 is equal to 1 for all n belonging to the set containing elements 1, 2, 3. Is you have to find the correct choice. It's clear that this can be written as f n plus 1 is equal to n into 1 minus fn. Keeping this relation in mind, it is obvious that if f1 is known to me, then with the help of f1 I can find the value of f2, and if f2 is known to me, with the help of f2 you can get the value of f3, and if f3 is known to me, then with the help of f3 you can get the value of f4. That is, for a unique value of f1, the value of f2, f3, f4 will also be unique. Hence, it all depends upon f1, how many values f1 can have. And once we have found all possible values of f1, you can find the value of f2, f3, f4 with the help of that. What I mean to say, see, I put n equal to 1 in this equation. I get f2 equal to 1 minus f1, and now putting n equal to 2, I will get the value of f3 as 2 into 1 minus f2, that is 2 into 1 minus f1, that is 2 f1. And once the value of f3 is known to me, now f4 will be equal to 3 into 1 minus f3 by taking n equal to 3 in this. That is, I get 3 into 1 minus 2 f1, that is 3 minus 6 f1. And now once f1 is known to me, then I can get the value of f2, f3 and f4. But this should be taken care of that the value of f2, f3, f4, all of them should lie between minus 8 and 8. That is, for timing now I am writing it as lambda. Then f4 becomes 3 minus 6 lambda. f3 will be 2 lambda. f2 will be 1 minus lambda. Hence, lambda should be such that f2, f3, f4, all of them lie between minus 8 and 8. This implies that 3 minus 6 lambda lies between minus 8 and 8. This means 2 lambda should lie between minus 8 and 8. And this means 1 minus lambda should lie between minus 8 and 8. And once we have got the possible values of lambda, we will get the number of functions. This implies that minus 11 is less than equal to minus 6 lambda less than equal to 5, and this means lambda lies between minus 5 by 6 and 11 by 6, and it means the possible values of lambda are 0 and 1 only, because I want such values of lambda so that this is also satisfied, that is, this is satisfied, and this means lambda should lie between minus 4 and 4, and this is subset of this. Hence, if this is true, this is automatically true. And lastly, this means minus 9 is less than equal to minus lambda less than equal to 7, that is lambda lies between 7 and 9, and this is also superset of this because I want all these conditions to be satisfied. Hence I have got the conclusion that the possible values of lambda are 0 and 1. That is, possible values of f1 are 0 and 1. And if f1 is 0, you can get the unique values of f2, f3 and f4. Hence, you'll get the one possible function in which f1, f2, f3, f4 are defined. For more clarity, I'm doing it. If we take the value of f1 as 0, then using this, I will get the value of f2 as 1 minus f1, that is 0, that is 1. f3 will be equal to 2f1, that is 2 into 0 equal to 0. And f4 will be equal to 3 into 1 minus 2f1. 3 into 1 minus 2f1, that is 0. That is 3. Hence f1, f2, f3, f4 are known to you. It was not required to find the value of f2, f3, f1, f2, f3, f4. Just for more clarity, I have done it. That is, if I have taken the value of f1 as 0, I have got the values of f2, f3, f4. Hence, we have got one possible function. Similarly, if I take the value of f1 as 1, then also you will get the unique values of f2, f3 and f4. In that case, one more function will be possible. Note that just for knowledge, one more thing I am going to tell you, and that is, for this case, function will be 1 0, 2 1, 3 0 and 4 3. This is one function. And similarly, starting with f1 equal to 1, we can get one more function. Hence, I can say fourth choice is the correct choice.